Despite its noticeable absence in many astronomy textbooks, many have argued that at the foundation of modern-day astronomy and math and science in general, no civilization should be more prominent than ancient India. And hopefully by the end of this video, you'll understand why. This is the 5th video in this series on the history of astronomy. If you're a returning viewer, it's good to see you again, and if this is your first time here, hopefully you'll find something you like. Astronomy has been practiced in ancient India as long as anywhere else in the world. However, its origins remain unknown. The earliest known civilization in the Indian subcontinent was the Indus Valley civilization, located in modern-day Pakistan. We do have evidence that this civilization was practicing some form of astronomy, but we don't know to what extent, as we haven't deciphered their writing, and in fact it's even debated if their writing was in fact a full-fledged writing system. One thing we do know is that this civilization was in contact with ancient Mesopotamia, at the very least through trade routes. But did other things travel along these routes? Like ideas? Was there any sharing of astronomical ideas between these two civilizations, and if so, in what direction? One of the big questions surrounding the Indus Valley civilization, sometimes called the Harappan civilization after the city of Harappa, is that in the middle of the Bronze Age, it disappears, and we don't know what happened to its inhabitants. One theory is that they moved further into the Indian subcontinent and became the local Indian population. If this is the case, it's likely that any ideas regarding astronomy they had would have been passed down to this Indian population. A few hundred years after the civilization disappears, we get the arrival of Indo-Aryans. These are people that originated in roughly what is modern-day Ukraine and Kazakhstan. And the arrival of these people mixing with the local population results in the ancient Indian culture we tend to think of, the culture that develops the Hindu religion and the Vedic texts. So the big question with ancient India, not just as it pertains to astronomy, but as a culture in general, is how much of that culture was brought by the Indo-Aryans, how much was from the local population, and is any of that local population derivative of the Indus Valley civilization? As far as astronomy is concerned, it's unlikely the Indo-Aryans brought any astronomy with them, as these were steppe nomads. Steppe nomads are not going to be carrying around books with star charts and astronomical equipment. That would not fit into their priority as nomadic people. So any astronomy practiced during this time would have originated with the local population. Does any of that astronomy derive from the Indus Valley civilization? We don't know. The arrival of the Indo-Aryan population triggers the Vedic Period. During this time, the Indo-Aryans gradually transition from being nomadic to semi-nomadic to a fully sedentary civilization. During this period, we have the first writings in Sanskrit. This is the period where the Vedas, for example, are first written down. The dates of when these were written down is a debated subject. The Vedas, while being mostly religious texts, do have some discussion of the cosmos. In particular, they have mentions of planets and eclipses, which they attribute to the work of demons. This does not suggest an advanced understanding of astronomy, so I would guess that these ideas probably came with the Indo-Aryans, and whatever astronomy was being practiced by the local population probably hadn't been transmitted to them yet. If you're finding this video interesting so far, please let the YouTube algorithm know and nudge them in the right direction by liking and subscribing, and maybe sharing it with some friends. During the Vedic period, we get the beginnings of Indian astrology, called Jyotisha. This was first written down by the earliest known Indian astronomer, Laggada. In his writings, we get the first mentions of Indian constellations and the Indian zodiac, which, just like every other culture practicing astronomy we've discussed, is a band of 12 or 13 special constellations through which the planets, the sun, and the moon all appear to travel. Laggada also writes instructions for practicing astronomy, rules on how to make proper observations. During the Vedic period, we also get a number of texts discussing mathematics and geometry, the most famous probably being the Shulba Sutras. By the end of this period, astronomy and mathematics are fully developed topics of research in the Indian civilization. Then, in the 4th century BC, the Indians come into contact with the Greek civilization as a result of Alexander the Great's empire. And this would trigger a sort of scientific explosion in ancient India as they remain in contact with the Greeks for many years. First with Alexander the Great, then when he dies with the Seleucid Empire, which is also a Greek empire, followed by the Greco-Bactrian Kingdom, and finally with the Indo-Greek civilization. This would take us up to roughly the BC AD switchover, 1st century AD or so. The first mention we have of scientific contact between the Greeks and the Indians comes from a Greek named Megasthenes, who lived in the city of Alexandria in Arcosia. Megasthenes was a contemporary with Alexander the Great, and he may even have been on his campaign. And he writes that the Indians, who he calls Brahmins, are practicing astronomy. Specifically, he tells us they know the Earth is round, and they have a geocentric model of the solar system, which, at least on these topics, puts them roughly on par with the Greeks. Over the next few hundred years, the Indians make a concerted effort to translate a number of Greek astronomical and scientific texts in general, and they start to mix their ideas with the Greek ideas. They even adopt some of the Greek constellations, and in particular the Greek zodiac, which is actually the Mesopotamian zodiac. This doesn't mean they take on Greek astrology, they keep their own astrology, but just map it onto the Greek zodiac. Unfortunately, this exchange of scientific ideas only goes one way. The Greeks don't really learn anything about the Indians, and that's mainly because the Greeks back home, back in Greece, don't believe anything Megasthenes or any other Greek writers writing about India say. You might think this is a bit pompous of them, but actually there's some good reasons for this. Megasthenes, and all these other writers, while they do report about Indian astronomy and mathematics, they also say a lot of fantastical nonsense about India, like there's people there whose ears are so big a man could sleep in them, or there's people with no mouths or people with spider legs. So as a result, everyone back in Greece is saying these guys are full of nonsense, even when they're reporting things accurately. Now I want to be clear here, the Indians do not become good astronomers as a result of the Greeks. They're already practicing astronomy and learn about this new civilization that's come to their borders that's also practicing astronomy and become very interested in what they've figured out. And then they start mixing the two ideas. So now we have a civilization that's accumulated all the scientific knowledge of two scientifically advanced civilizations. Following this contact with the Greeks, we get what is sometimes called the Indian Golden Age. The Indian Golden Age more or less starts with the Gupta Empire, maybe a little earlier, but many of the mathematical, astronomical, and scientific findings in general from ancient India that you may have heard of come from this empire or shortly after. This is where we get the beginnings of the Hindu numerical system, the decimal system, the system almost the entire world uses today. Probably the most famous Indian astronomer of this time was Aryabhatta. Aryabhatta was a prolific astronomer. A few of his notable achievements were measuring the Earth's circumference. Using the similar method, he also measures the speed of the Earth's rotation. Aryabhatta is also the first person we know of to suggest that a planet's orbital speed in the solar system is related to how far it is from the Sun. This proposition, 1,000 years later, would be shown to be correct by Kepler and then explained by Newton. This suggestion has been used by some to argue that Aryabhatta supported a heliocentric model of the solar system, a model where everything orbits the Sun. However, he does write explicitly that he supports a geocentric model, meaning the Earth is at the center of the solar system. But maybe as a result of his data, he realized something was not quite right with his geocentric model and started to spitball new ideas. Or maybe he just changed his mind and moved to a heliocentric model later on in his life. Once the Indian Golden Age is triggered, there are so many Indian astronomers and mathematicians that there's no way I could possibly cover them all in this video, so I'm only going to mention what I consider to be some of the more important milestones. After Aryabhatta, we get another famous astronomer named Varahamihira. Varahamihira is also a prolific astronomer, but he's most known for having compiled a sort of astronomy encyclopedia of everything known to the Greeks and the Indians. So now we have all the ideas and discoveries in the field of astronomy from both of these civilizations compiled into one book. A little bit later, we get a man named Bhaskara I. There's a second Bhaskara a few hundred years later. Bhaskara, like all these other guys, was a polymath, dabbling in astronomy, math, and sciences in general. But probably his most important contribution was that he finalized the Hindu numerical system. He didn't invent the Hindu decimal system, it already existed before him, but the symbols hadn't been finalized yet. Before Bhaskara, the Hindu numerical system was not widely in use. It was mainly used by astronomers because they had realized it made their calculations a lot easier. As a result of Bhaskara, the Hindu numerical system becomes widely spread in all of India. Later on, we come to Brahmagupta, maybe the most famous mathematician in all of India. Brahmagupta did a lot more in the field of mathematics than astronomy, but he is often credited as the first person to suggest the existence of gravity. This is somewhat debatable. What he says is that objects fall because there is a force attracting them to the Earth. Now, this sounds like gravity, but it's a little bit vague. What exactly does he mean by force, and how does this force work is not really clear. He doesn't give a mathematical description of the force. Even today, the word force is often used colloquially in a way that has nothing to do with the way it's defined in physics. It also only applies to things on Earth. He does not make any suggestion that the motion of the planets is a result of gravity as well. He essentially just says things fall because they're attracted to the Earth, but in what way he doesn't clarify. But it does sound something like gravity. So, does this qualify as gravity? Well, let me know what you think in the comments. The final Indian astronomer I want to bring up is Satyananda. Satyananda makes the most accurate measurement of the precession of the equinoxes to date. To date meaning up to his time. You'll recall if you've seen my previous videos in this series that precession of the equinoxes refers to the wobbling of the Earth's rotational axis over a period of about 26,000 years. Satyananda measures this precession to about 1 degree per year, which would give it a period of 21 to 22,000 years. Now at this time, I don't think anyone's actually figured out that this drift is actually periodic as opposed to just a gradual linear drift, as the explanation for the precession of the equinoxes hasn't been figured out yet. So far in this series, we've discussed civilizations that are largely independent of one another. Greek astronomy is really just a continuation of the general Middle Eastern astronomy started by the Egyptians and the Mesopotamians, but the other three all develop astronomy independently. After the Indian Golden Age, all of these civilizations start to know about one another, with the exception of the Maya, who are in the Americas. Now astronomy is no longer developing independently in various civilizations. We just have astronomy as practiced by the entire world. Before we move on to this next phase in astronomy, I want to discuss trigonometry. Trigonometry is developed largely for the purpose of practicing astronomy. And typically we are taught that trigonometry is a primarily Greek invention. But the Indians and the Chinese also develop it independently. And if we take a look at the Greek system, the way they do it is they define an angle inside of a circle and then ask what is the length of this chord. But if you remember from your trig classes, this is not what we do today. What we do today looks a lot more like this, the Indian system. We define an angle on a circle and then make a right triangle and ask what are the lengths of the opposite and adjacent sides, which we call sine and cosine. So even though we always think of trigonometry as a Greek creation, we're using the Indian system. In fact, the word sine is derived from this Sanskrit word gia. It results from a mistranslation into Latin from an Arabic text. The Arabs adopted the Indian system and took on this word gia. By the way, the Greeks did all their trigonometry using a compass and a straight edge. That's not how we do trigonometry today, at least for the most part. Our trigonometry today is largely algebraic, using the Hindu numeral system. So as far as math is concerned, we pretty much get everything from the Indians. We get the numerical system from the Indians, and we get our trigonometry from the Indians, not the Greeks. Yes, there is a Greek influence as well, but we use the Indian convention because it was adopted by the Arabs. And really, our trigonometry today follows the Arab system, as the Arabs develop algebra and 6 trigonometric functions. So we have an algebraic system of 6 functions: sine, cosine, tangent, cotangent, cosine, cosecant. And all these algebraic identities between them, most of them were developed by the Arabs. The Indians and the Greeks only developed 2 or 3 functions. But at the foundation is the Indian system, not the Greek system, even though the Arabs are also studying Greek trigonometry. So now I hope you understand why I said at the beginning of this video that many people consider ancient India to be at the foundation of modern day science. For sure, there's no question that modern mathematics is built off of ancient India. We're using their numerical system, as it's far superior to any other numerical system anyone's come up with. The only issue I have with it is that they should have picked base 12. Base 12 makes calculations much easier than base 10. As far as astronomy goes, you can argue between who was more foundational, To our modern day astronomy, the Indians or the Greeks, or I should really say the Eastern Mediterranean Middle East area, so Greeks, Egyptians, Mesopotamians. Personally, I would probably give a slight edge to the Mediterranean area, but the Indians are right there. Now we come to a civilization that has been completely forgotten in the history of astronomy, math, and science in general, and no, I'm not talking about the Arabs. I'm talking about a civilization that is so unknown that I don't even know that there's a name for them, so I'm going to call them, for the lack of a better term, the civilization of Transoxiana. Transoxiana means the other side of the Oxus River here. Although they're not only located on the other side of the Oxus, they're located in this general area, which more or less comprises of the modern day states all ending in Stan. This civilization was the center of the Silk Road, and the Romans referred to this part of the world as the land of 1,000 cities. If you've got 1,000 cities, you're a major civilization. I'm willing to bet almost none of you have even heard of this civilization, and certainly not its influence on astronomy and science in general. I myself had never heard of it until I read this book by Central Asian historian Frederick Starr. So if you're interested in forgotten or lost civilizations, and if you enjoyed this video, be sure to like and subscribe, and hit the bell to be notified for the release of future physics videos. Thanks for watching, and I'll see you in the next one.